All right, welcome everybody. Hello, hello in the back. My name is Pam. Oh, so please silence your cell phones or not, whatever. If you have to take a call, please feel free to step out. You won't offend me, it's okay. Yes, explore everything PASS has to offer. I highly recommend doing that. Okay, so me. My name is Pam Lahoud. I am a program manager on the SQL Server engineering team. My focus is on the storage engine area, but I also like to do things like performance tuning and stuff like that. And also, because half our team is at Ignite, everyone's an expert on everything this week. So I'm coming to you today to talk about accelerated database recovery and other goodies as far as availability. One thing, and I'm SQL Goddess on Twitter. One thing I did want to plug a little bit is you may have seen that we're doing something different this year with learning pathways. So these are collections of sessions where we've really kind of thought through a pathway of learning. So not just a single session, but a series of sessions that kind of go hand in hand. And we're doing one, Modernizing with SQL Server 2019. I guess that looks a little small. And of course, I can't zoom it on this thing. So there are a few different sessions that are kind of like a journey through 2019 and how to get there. And so I have a session tomorrow on modernizing your SQL Server the right way. It's one that we've been doing for a while. If you've done the past Modern Migration Tour, it's kind of similar to that. And then I highly recommend Pedro's SQL Server Migration the Last Mile that talks a little bit about database compatibility and how to upgrade your database, and then the other stuff. So you've already, sorry, too late. You've already missed Bob's what to use when. But if you didn't see that, then definitely go look at the recording for that, because that's a good one for like, okay, you have all these Azure data services. Which one do I pick? So that's a good session for that. And then right now, you're not in Bob's session. Cool. You're with me. So just a little bit of the other goodies that you'll get from the Microsoft team here this week. Okay, so enough about that. So I called this session Improving Availability. And I know that word availability usually generates something different in your mind. You're thinking about, I don't know, clusters or availability groups. It's got the word availability in it, right? You're thinking disaster recovery. You're thinking all of those things. But availability means a lot more than that. You could have the best HADR strategy, but if someone is running a giant query that's blocking everyone from using the database, your database may not be available. And so that counts as downtime for your application. If your application cannot use the database, then it's effectively down, even if your server is up and running and the CPUs are pegged at 100%. So what we are talking about when I'm talking about availability here is the system up and is it usable by everyone? So that's what these features are about, is making sure that, yes, you've got availability groups, you've got clusters, you've got all those layers of infrastructure that help you keep the system up and running, keep the server up and running and the service up and running, but can you actually use it? So that's what we're talking about as far as availability here. So we are going to talk about 3 different technologies. Some of them are new for 2019. Some of them are not. They started in 2017, and we've just improved upon them in 2019. So the first one is accelerated database recovery. Also, we generally abbreviate it as ADR. So if you hear anyone talking about ADR, that's what we're talking about, accelerated database recovery. And that's your near instantaneous recovery upon startup and rollback. This is what we talked about in the keynote today that everyone got super excited about. And the other one is online index improvements. So the ability to do online index create and rebuild in a resumable fashion so that you don't have to do it as one atomic operation, and that solves a bunch of different problems. We'll talk about that. Yeah, I saw some jazz hands. And the last one is Resumable Encryption Scan. Actually, I changed the order, so we'll do Resumable Encryption Scan first, and then Online Indexing Improvements. So Resumable Encryption Scan, this is for if you're using transparent data encryption, or TDE. Whenever you turn it on or you need to rotate the database encryption key, it requires a scan. So that's we've made that resumable as well. So that's what we're going to talk about. OK, so let's start with what everybody came here to talk about, which is accelerated database recovery. OK, so first, how many of you have faced the situation that Bob and Connor were acting out today, where, yeah, I see the hands, long-running query. Oh, no, no one can access the database. What do we do? Kill it. All right, it's not dead. When's it going to die? And then you refreshing, it's still there, and the locks are still there. What's happening here? And then, yeah, I've had a number of people say, what can I do? I'm like, you can't. Don't restart the server. Trust me, it might take even longer, right? So there really wasn't anything that you could do. And this is an age-old problem. And they actually mentioned it in the keynote. Why do we have to solve this problem? Because now we're the ones running the database in Azure, and we were having the same problem. So we're like, OK, there's got to be a better way to do this. OK, so the first thing is recovery. So in the event of a failover or restarting the database has to go through recovery. And if you've got that long-running transaction, the reason why the database won't just come right back up after you restart the service is because we have to go through recovery. And recovery is when we go through the transaction log and we make sure everything that was committed before the crash or the restart is in the data file, and everything that wasn't committed, that was in flight, is rolled back, is moved out of the data file, right? So that takes time, and it's generally proportional to your longest running transaction. So if you go ahead and kill that transaction, and then you just try to restart the server, you're not shortcutting anything. You still have to go through that same process. It's just now the database is completely offline until it's done, or maybe halfway through it's done. We'll talk about that in a second. OK, so rolling back those large operations takes a long time. That's why you killed it in the first place. You were trying to roll it back with, or you had this long-running transaction. You kill it, you try to roll it back, takes forever. So that obviously takes a long time. But the other thing is, you could run out of transaction log space. If you get yourself into a really severe pickle and you've got this long-running transaction, the other thing is, what can you not do if you have an active open transaction? Anybody know? Truncate the log, right, I heard that. I heard truncate from a lot of people. You can't truncate the log. What does it mean to truncate the log? It means I can overwrite what's in there. I can reuse that portion of the log. So if I have a long-running transaction, even if every other transaction in the system is committed and I've got a huge portion of the log that's ready to go, it doesn't matter. That oldest active transaction holds all that log open, and it's not able to truncate, cannot reuse that space, and your log file will just keep growing. And so you could, in theory, run out of disk space, and then you're really in trouble, because you may not even be able to roll back at that point, right? OK. So those are our big 3 pain points. So just a little numbers for you. 60% of customers surveyed have experienced more than 1 hour of production database unavailability due to long-running recovery. So, and if you've got a failover, if you've got an unpredictable failover, this could happen any time of the day. You just don't know. OK? All right, so what is accelerated database recovery? It is a new SQL Server engine feature. I'm calling it, I actually should have said database engine feature, because it's both in Azure and in SQL Server, that greatly improves database availability by completely redesigning the current SQL Server recovery process. So we totally changed the way recovery works, and that's what we're going to talk about today. So fast and consistent database recovery, instantaneous transaction rollback, woohoo, and aggressive log truncation. So that's the part they didn't really talk about. They told you how fast it is, but the other thing is, it will help you with your transaction log maintenance. It will also hopefully keep your transaction log smaller. OK, so let's talk about the current database recovery process. OK, so what I've got here, it's kind of hard for me to laser point on that. Bear with me. If you have any questions, let me know. Maybe I can mouse a little bit. Nope. OK. Let's just give up on that idea. OK. So what I have here is, imagine this is your transaction log. So you've got the log start. Then you've got the oldest uncommitted transaction. That's the one that's holding. That's what we call the active part of the log. Then you've got the checkpoint. Does everybody know what a checkpoint is? Yeah? OK. What does a checkpoint do? Flushes pages out to the data file, right? So the checkpoint being there means everything before that checkpoint is already on disk. So all of that is written out on disk. Normally, I would be able to then then truncate this log, but because I've got that old active transaction, I can't. So that's our last checkpoint, and then I've got the log end. OK, so I'm going to recover. So I restart the SQL Server. The first thing I have to do is phase 1, which is the analysis phase. So I have to look at the log and see, OK, what's the state of each of these transactions when the server was brought down? OK, so what's open, what's closed, what got checkpointed, what didn't. So then phase 2 is what we call the redo phase. So the redo phase is what returns the database to the state it was at the time the SQL Server stopped. So anything that was not written out to the disk, so I look at all those transactions and I write all of those changes that were in memory only, I write them out to the disk. And if you're an enterprise edition, then the database is partially available after the redo phase. That's what we call fast recovery. You may have seen that as a feature called out in documentation in a few places. So fast recovery is something we introduced to, again, to try to shorten the time it takes to do a failover. So with fast recovery, the database is partially available after the redo phase, but then comes the undo phase. And in the undo phase, we need to roll back any uncommitted transactions. And they need to be, and again, we're rolling through the logs sequentially, rolling back whatever was uncommitted. So that can take time. And this is one of the reasons why recovery takes a long time if you have a long-running transaction, because there are a lot of records that need to be undone. Okay, so that's the undo phase. And if you're in standard edition, your database is not online at all until the undo phase is complete. If you're in enterprise edition, you're only partially available until undo is complete. Okay, so that's generally the part that takes a really long time. And sorry, let me just say that. Yep, database is fully available after undo. And so what you will see in the error log is these messages periodically being printed. Database is 1% through recovery, 2% through recovery, right? And we just keep printing that in the error log until the database comes online. OK, so that's the way recovery works without accelerated database recovery. OK, any questions about that before we move on? OK, cool. So let's talk a little bit about the components of accelerated database recovery. That's kind of small. Let me see if I can make that a little bit bigger, because I'm a little bit missing my zoom it on this machine. OK. Sorry. There we go. Let's do that. Hopefully that helps. OK. Maybe not. OK, so persisted version store, or PVS. This is a new component that was introduced to support accelerated database recovery. And you may have heard of a version store before. Anybody using Snapshot Isolation or read committed Snapshot Isolation? Yeah? Good portion of you. So that uses a version store. Where's that version store stored? TempDB, right? Where is this version store stored? In your user database. Okay? So if we were to keep the version store in TempDB, it would not be persisted, because TempDB is recreated every time you restart the server. So it wouldn't be persistent. Obviously, we wouldn't be able to use it for recovery if it disappears. So the persisted version store is moving the version store out of TempDB and into your user database. Okay? The row versions are stored in row if we can. If not, we can store in an off-row version store. And that off-row version store is a separate area which you can actually redirect to a different file group if you would like to. So that's a possibility if you are thinking of turning this on and you're concerned about where those row versions are going to go and disk space and things like that. Okay, so that's the PVS, or the persisted version store. Incidentally, when we started doing PVS, we had to do a couple other things that we normally had to do to TempDB, like fix PFS page contention. You remember that? Why do you have multiple files in TempDB? This is one of the reasons you have concurrent PFS updates now, because we needed it for ADR now that we're starting to write row versions into your user database. Okay, logical revert. This is an asynchronous process that is handling that row-level version-based undo. Okay, so background process that does the undo. I'm going to talk about how these all fit together in a moment. SLog, secondary in-memory log stream. So what the SLog is used for is for changes that need to be logged that do not fit into row versioning. So system-type transactions, things that we normally write into the transaction log, but they're not necessarily a row version. Okay, so that's the SLog. And then the last is a cleaner. So there's a cleaner, an asynchronous process that cleans out your row versions that are no longer needed. So of course, now that we have row versioning, and keep in mind, if you turn on accelerated database recovery, all of your row versioning-based isolation levels will now use the PVS. They will not use TempDB anymore. So as soon as you turn on ADR and we get the row version store in the database, you turn on Snapshot Isolation or read committed Snapshot Isolation, we use those same row versions. So it's not like we have two different version stores. We just convert to using the local one. Okay, so that means, if you're using one of those Snapshot Isolation levels, you may have to keep row versions around for a while, because if you have open transactions that are using older versions, we can't clean them up. So the cleaner is responsible for going through and cleaning up those row versions that are no longer required. By default, say again? ADR is disabled. Yes, oh, correct, yeah, that's a good question. Yeah, so the question is, by default, ADR is disabled. Yes, in SQL Server, this is an opt-in feature. Okay, yeah?
How does it relate to the garbage cleanup that cleans up ghost records?
How does this relate to the ghost record cleanup? It is a different process altogether, and the rules are different. I don't know the detailed algorithms for what it uses, but it has to do with active open transactions and things like that. Whether things have been checkpointed, whether I still have handles on those rows. Where ghost cleanup is a little bit different because those have already been deleted and I don't need them anymore. So it's a separate process. Another question. Okay, so the question is an opt-in feature. Is that because there are risks? I will talk about that a little bit. In fact, I have an FAQ slide here. So let's hold the extra questions for now. If they don't get answered by the next 2 slides, then I'll take more questions, okay? Okay. So let's talk about how all this fits together. So here's my same diagram of the log, but this time you'll see there's some red things in there. Those are your SLog records. So those are those records that are not in the PVS or the row version store. Okay. So phase 1 analysis. So this is basically the same as it was before. The only difference here is we reconstruct the SLog, because remember, the SLog is in memory. So during the analysis phase, as I'm going through the log, I'm taking all those SLog records and putting them back into the in-memory SLog. Okay, so that happens during the analysis phase. Okay, there's my rebuilding the SLog. There we go. Yay, animation. Okay. So now the redo phase is very different, because that giant portion of the log that happened during that checkpoint, that's already in the database because all those row versions are there. So in order to redo this, all we have to do is know which one of those row versions is the valid one. Everything's already there. So that part is just redoing the SLog records. Okay, so the SLog records are redone. And then the only thing we have to redo in the traditional way is what happened after the checkpoint, because the checkpoint is the last time we flushed anything to the data file. Okay, so after the checkpoint, that's stuff that was in memory only. We need to recreate that. So the redo phase becomes much faster, and then guess what? The database is fully available after the redo phase because undo is instantaneous. Because undo just means all of those versions are invalid. We don't care about them anymore. Go back to the original versions. They're all still there. It's just a matter of telling any new transactions, ignore those row versions, only look at these row versions. That's why it's instantaneous. It's all based on versioning. Okay? All right, so let's go to that ADR FAQ. So question 1, will my database be larger? What is the answer to this question? Yes. Yes, your database will be larger. How much larger? I cannot tell you without testing. Why? It is dependent not only on your database size, but on your transactions. The more things you have changing rows, the more row versions you have. The longer running your transactions are, the longer we need to keep those row versions hanging around. So the answer to this question is yes, it will be larger, and you should test with a production-like workload to see how much. Now, if you're already using snapshot-based isolation, you may have a good idea of how big this will be because it could be similar to what's happening in TempDB. So you might be able to measure the number of row versions and the space used in TempDB and get sort of an idea, but honestly, it's a different mechanism, so it's not gonna be a one-to-one thing. It's not like we're just copying what was happening in TempDB into the user database. There are differences in how things happen, and there are optimizations that happen as well. So it's not gonna be exactly the same, but at least it could give you an idea of like, are we talking about billions of rows or are we talking about, thousands of rows, okay? So, question 2, will it affect performance? What do you think? It depends, of course. Of course it depends. What does it depend on? Well, one thing it depends on whether or not you're already using snapshot-based isolation, right? Because if you're already using snapshot-based isolation, you're already doing double writes, right? So in theory, you could already be suffering some of that overhead, and in this case, you might just be moving it from TempDB into the user database. If you're not already using row versioning, there's probably gonna be a hit there. Now, how much is that hit? Well, the more write-heavy your workload is, the bigger the hit is going to be. So like, in some of our TPC benchmarks, the hit was like 5%, 10%, and other ones that were like crazy write-heavy, it might have been more. So there absolutely will be a performance hit. How much it will be is totally dependent on your workload. So again, you need to test. But the other thing is, like, what is your availability worth to you? A lot of times, just that little extra hit is just worth it in spades when you can have the peace of mind that you can roll back a transaction instantaneously, or that a failover takes like milliseconds instead of minutes or hours even. How is PVS different than the version store in TempDB? So first, it stores it in the user database versus TempDB. And like I said earlier, if ADR is enabled, PVS is used to support snapshot and read committed snapshot isolation. So that's kind of cool. Take some work out of TempDB, take some load off TempDB. How does this affect availability groups? Now this one is kind of cool and not something that you might have thought about. So because the persisted version store is in the user database, those rows and log records are all replicated to the secondary. So all of the communication about our oldest transactions and all of that is communicated to the secondary, and then if you have a readable secondary, the row versions that readable secondary needs is communicated back to the primary so that the cleaner knows how far back it can clean, okay? So the primary and the secondary are talking to each other. So first of all, of course, ADR can speed up failover because the recovery is so much less, right? You're redoing those row versions on the secondary at the same time as redoing the actual transactions. So all these row versions are already going to be there on the secondary. But here's the kind of cool part. What if you have to restart your secondary and you have a full read-only workload? Anybody knows what? So I don't know if everybody knows this, but when you have a readable secondary, what do we do to your isolation level? Do you guys know? Snapshot, right? We automatically have to turn on snapshot isolation. So what that means is on your readable secondary, those row versions are being written into TempDB, but they're being written into TempDB on the secondary server, okay? So as your read workloads are coming in on that secondary, they're generating row versions that are going into the TempDB on the secondary. So then what happens when you restart the secondary? You lose them, right? Because TempDB gets recreated every time we restart SQL Server. So if we restart your secondary, you lose all those row versions. So as your read-only workload starts coming back into your secondary, those row versions are gone, okay? So what needs to happen is those queries might get held up waiting for things to commit on the primary and those new row versions to come over to the secondary. So this could actually delay your read-only workload on the startup of your secondary server even. So with ADR, you restart that secondary server, you didn't lose any of those row versions. They're all there. And so there's no delay there. So this could actually really be beneficial in an availability group scenario, particularly one where you are using readable secondaries, okay? All right, how do I get it? Azure SQL Database, do nothing, it is on by default. So if you are using Azure SQL Database, you already have this. And you don't have to worry about it because you're not the one being woken up in the middle of the night anyway, but it's there. SQL Server 2019, alter database name, set accelerated database recovery on, and that's what starts the PVS and starts all that going. And the last question, do I need Enterprise Edition? No, you do not. This is in Standard Edition. Pause for applause, no. Okay. All right, so I know I have questions. You're pushing your luck at the Express. It's not available in Express. Question back there. So for the version store, can you move it to a dedicated file group? So the answer to that question is sort of. Some of the versions are stored in row with the data itself, but there's an off-row version store, and that, yes, you can move into its own file group. OK, question here.
Due to our high transaction rate, we've had issues with background cleanups before. Is the cleanup for ADR configurable at all?
So due to high transaction rates, you've had issues with cleanups in the past, not keeping up with your transactions. Is that what you're saying?
Yeah, for drop, garbage cleanup, all kinds of
OK,
things.
so is this configurable in any way? Not that I know of. And of course, I don't know where you might have issues yet, because it's relatively new. But that is something you could follow up with me on, because I can definitely talk to some of the other folks who were working on this and see. I don't think there is anything now, but there may be something coming down the pike, so I'll find that out. Yeah?
What's an example of a transaction that would end up in the S log?
What's an example of a transaction that would end up in the S log? That's a good one. I'm guessing things like DDL type changes, like changing the structure of objects, anything that's going to hit system metadata. I don't know that for sure. That's just from my own logic. So you can follow up with me later if you want to confirm. But that'd be my guess is that's one good example. Yeah. OK. OK, so the question is, what determines whether the version comes on row or off row? So there's some fancy algorithms that they've got going on, some optimizations. There's a research paper that they have written for this. It used to be called constant time recovery. So if you guys look up for that white paper, I think I might have had a link in it in the slide deck, but I'm not sure. So constant time recovery is what this used to be called. Check out that white paper, and I think they talk a little bit more about the algorithms that they use to decide whether to create row versions at all. Because if you're just modifying one row, they don't bother, for example. So there's definitely some complicated algorithms there to decide that. OK, one more question, then we'll go to the demo. Is there additional overhead on the memory footprint for the S log? I mean, in theory, yes, it's a new thing that's in memory, but I would imagine it's a drop in the bucket. I'm sure it depends, of course, on how much you have, but it's a small percentage of your log records, so it shouldn't be. OK, one more question and then. Does it affect the backup time? That's actually a really Good question. It's going to affect the size of your database. So in theory, it could affect the backup time. Yeah, because it should get, those versions will, if they're there, they're going to get backed up as well. So yeah. Okay, I lied. One more question and then demo. In the back. Okay, I'm sorry, I couldn't hear you. Do the table stats get updated? Like your data distribution statistics? Like your just the column stats. Oh, like update. Yeah, I mean, this shouldn't affect any of that metadata. Because it's not really, like if you modify a column, you modify a column, whether I create a version or not. So I don't think it should impact that at all. But come to me after and we can talk a little bit more because I want to make sure I understand your question. Okay, demo. And water. Important to stay hydrated. All of you, I'm watching you. Okay. How many of you have seen notebooks yet this week? Yeah? Well, we had some in the keynote, right? Cool stuff. Really cool stuff. So all my stuff is in a notebook, so if anything breaks, it's cool, because I've already run it all. So I stole this from Bob Ward from his SQL workshops, aka.ms WAC SQL workshops. Lots of good stuff out there. We also have a lot of these notebooks out on aka.ms WAC SQL 2019 notebooks. So if you want to do any of these demos yourself, they're out there. The one thing, though, that I did change, which I thought was really important, is you guys know that Bob is a Cowboys fan. So his databases always go Cowboys, and I just couldn't do it. So I changed it all to go Seahawks. I'm not even a Seahawks fan. But I'm a Patriots fan, and I didn't want you guys to throw tomatoes at me, so. Yeah, right? I heard the groans. Oh my God. You guys, I was born in New England. I grew up in New England. It has to happen. As a Bears fan, you can totally, I will give you sympathy. Okay, so what I did here is this can sometimes take some time for me to create this database. So I've already run this. I've created this database, and I've created the table, how about them Seahawks, Russell Wilson rules, instead of whatever cowboy he had in there. And now what we're going to do is I'm going to begin a transaction, and I'm going to delete the entire table. Oops, I forgot to put the where clause on my delete statement. Oh, no. OK, let's do it. Thank God I did begin tran. You know, when I was a DBA, I learned that the hard way. Just put a begin tran before anything you do, just in case, right? Just in case, because I have definitely highlighted the delete part of a statement without the where clause before. So not my first rodeo. OK, so that took about 11 seconds to run. Are you guys seeing that OK in the back, by the way? Can you? OK, good deal, because I do have Zoom it in case. I heard it's the new free bird of SQL Pass. Zoom it. So feel free to shout it at me if you need it. OK, so let's see how much transaction log space is used. Let's look at this. OK, log space used in bytes. I need commas here. 1, 2, 3, 4. That's like a lot of, that's like gigabytes of log space used. OK, so huge amount of log space used. OK, well, can I checkpoint? If I checkpoint, will it truncate the log? Let's see. Checkpoint. Nope. That looks like the same number. I mean, it's a little bit different, but it's huge. It's still a huge number. So I've got a lot of space. And now my log file is 79% full. So if I'm continuing with workload, I'm in trouble, because checkpoint is not truncating this stuff. So, and I'm in simple recovery, by the way. It's not that I didn't back up the log. I'm in simple recovery here. So I'm in trouble if this keeps going. OK, so OK, well, we better kill that transaction. Let's kill it. Roll back. Now here's one kind of annoying thing about notebooks. You can only run one query at a time. So while this thing is running, I can't do anything else in this notebook, and it's going to take a while. So we'll just chat for a while this thing is rolling back. OK, so by the way, I should mention, obviously, I haven't turned on accelerated database recovery yet, so this is going to take some time. OK, 19 seconds. That wasn't too bad, but definitely longer than I'd like. OK, so what's the log space used after a checkpoint? Well, now it's small. Now I'm only using 1% of the log. So that giant transaction took up a huge portion of my log, and it wasn't until I rolled it back that I could get all that back. Okay, so how are we going to do things differently? We are going to alter database. Go Seahawks! Set accelerated database recovery on. This is super easy. Don't highlight that, just run it. Okay, done. Now we're going to do the same thing. Begin tran, delete. Forgot my where clause again. Now this part's going to take the same amount of time. In fact, that part could sometimes take longer, right? Because I've got row versions and stuff. So that's not faster. What's faster is let's do a checkpoint. Oops. Did I have that highlighted? No. Okay. Did I do both of them? Yeah. So okay. So I was 20% log space used. Then I did a checkpoint, and it actually did clear the log. In this case, it's 7% used. So a couple things to note here. My log space usage is much smaller. Why did I use less log when I did this transaction? Right, so there's a lot of muddiness, but what? Right, so the row versions are in the data file. That means I don't have to write them to the transaction log file. Okay, the row versions are in the database itself. So I don't have to copy them all to the transaction log. So I don't have as much stuff in the transaction log, right? And then when I do the checkpoint, all I have to do is just say, okay, those row versions are done. They're no longer needed. And then eventually that cleaner process will come up, and it'll clean those versions out. That's how it works now. Okay, so I haven't even rolled this back yet, actually. I just checkpointed without a, yep, sorry, you had a question?
So sometimes when we do the SQL backgrounds every 30 minutes or 15 minutes, and we need to
Yep.
the database, happens that we install two backups overnight, and then every transaction log until a point in time.
Yep.
Before it was longer sometimes to apply the transaction logs backup because so many big transactions. Is this going to make all these transaction logs?
Okay, so the question is, if I have to restore from transaction log backups, is it going to make that faster? What is your guess on that? What do you think? Probably not. You know why not? Because the row versions are not in the. You're backing up the. When you have full recovery, we can't truncate the transaction log because we need all that stuff in there. So I'm still going to have to recover. So yeah, because I do still need those row versions in the transaction log if I'm in full recovery model. So I'm in simple recovery model here. So I don't need to keep those things around. So that's the part that's different. In fact, I think I may have, did I explain that? Yeah, you guys are looking at me like I'm crazy. Okay, I think what I said before was that I wasn't writing as much into the log. The truth is I do still have to write that into the log. What I don't have to do is keep it hanging around, and I'm able to, like everything else that happens after that transaction, I'm able to truncate all of that, sorry. So I think what I said was wrong. I think I said you don't have to put it in the log at all, but you do. Yeah, I have to write to the T-log first. So it's not that I'm not writing, it's just that I'm not keeping it around, sorry. Yeah, so in simple, I don't have to keep it around. But in full, I do have to keep it around. Okay, sorry about that. Okay, so roll back. Did you see that? Yeah. 2 milliseconds, right, versus 20. So that's huge. That's a huge difference. Okay, so that's accelerated database recovery. More questions? Okay, cool. Oh, are there any new system tables or views that you should look at? There are some new system tables, and I'm sorry, I didn't think to copy any of those into my demo or into the deck, but there are. But they should all be documented. So I would just look up accelerated database recovery, and you should be able to find stuff there. Okay, sorry. Yeah. Okay. Uh-huh. Uh-huh. Okay, so you have a SAN level snap of the database, and you need to attach that snap and then recover? Sometimes the database you took a snap of has a long transaction and the recovery takes a long time. Yeah, so I think the answer to that question is that, because any recovery should be faster, what I'm not clear about is how your SAN snap works. Like, is it just like, is it doing a VDI backup or something like that? That might come into play. So I think it probably should be, but I can't tell you that for sure unless I understood exactly the architecture behind it. Okay, but I can definitely hook you up with someone that can talk about that. Okay, where are we at for time? We should be fine. Okay, I can take a couple more questions. There were a couple more hands. Yeah? So does anything exist to read the S-log, a view to read the S? Yeah, so I believe we do have like views for all of that. I just don't know what they are off the top of my head. So we can look that up. Again, come see me after the session, and I'm happy to see if I can find some of that. Yeah. The SAN snapshots. So I believe it's the same. I just have to think that through a minute because that's one that I haven't thought through. And obviously, I'm not thinking on my feet right now because I'm getting sick. So because I just told you don't have to write stuff into the log, and I was like, wait, that's not right. So come to me after and let's talk about that.
High VLF counts versus a proper VLF count. How does that impact this at all?
Well, in theory, your log growth should be less. So the question is high VLF counts. Will this impact your VLF counts? Generally, your VLFs get out of control because you're auto-growing, auto-growing, auto-growing. So in theory, if you're not auto-growing as much, your VLFs should stay under control. But I think that's probably another it depends question. So yeah, that's what Pedro's shaking his head. Thanks, Pedro. One more. Yeah. So the question is, if I have bad fragmentation in the database itself, could this affect that? So that's actually a good question, because you might immediately think, what does fragmentation have to do with this? Well, we are putting some of these row versions in row. So in theory, it could be making your rows a little bit bigger. So it could, in theory, influence your fragmentation. I have no details on those numbers. So that's just out of knowing how it works. I can see how it could influence it, but I don't know that would be my biggest concern, though, honestly, because it's going to be in memory anyway. So, I mean, yes, it matters if you're doing the I/O to bring stuff into the buffer pool. It's going to matter, but that would probably be not a huge worry for me. But that's obviously something you could monitor, right? Okay, another question in the back. Oh, if it's already on default in Azure, is there a way to turn it off so that you could see the difference? My guess is yes. Yeah. Oh, that's right. It's an alter. You can do the alter database and turn it off. It's just on by default. Okay, yeah. So you can do the same alter database command and just turn it off. Yeah, I was thinking, do they need a feature switch? But no. Okay, you can just turn it off. Cool. Okay. All right. Cool. Let's move on. Okay. Okay. Okay, conflicting information. So Joe is saying he's pretty sure the last time he checked, you weren't able to run that database command in Azure. So we will verify that. There's definitely a way to turn it off. The question is, can you do it yourself, or do you have to call Microsoft to do it for you? Okay. So, and feel free to come to me afterwards if you have more ADR questions. I just want to move on to the last two topics, because we have about 30 minutes left. Okay, so Resumable Encryption Scan. This one's super easy. I'm not going to spend too much time on this. I don't have a demo on it, because, I don't know, it's kind of boring. But it's cool in that if you have to do this a lot, this is a big deal. So the encryption scan is what happens when you turn on TDE, transparent data encryption. We have to do an initial scan of the database. So that also happens anytime you need to rotate the database encryption key. So not the key that encrypts the key, but the database encryption key itself, the one that actually is used to encrypt the data. If you rotate that for any reason, then we have to do another encryption scan to re-encrypt the database with the new key. Okay? Incidentally, this also happens when you turn it off. when you turn TDE off, we have to, again, unencrypt everything. Okay, so that's what we mean by an encryption scan. The way that encryption works, so with transparent data encryption, the data is encrypted at rest on disk, but it's unencrypted in memory in the buffer pool. So where this encryption and decryption happens is in the I/O process when we are moving pages between the disk and the buffer pool. So the way the encryption scan works is just by dirtying every page and forcing it into the buffer pool. And then the normal I/O processes, checkpoint, lazy writer, those are the things that actually do the encryption. So all the encryption scan does is go through your entire database and dirty every page. But if your entire database is like terabytes, that can take a long time. And I'm putting things in the buffer pool, so if I'm putting all these pages into the buffer pool, I don't have as much room for your queries, right? Because I'm just using that, it's the same buffer pool that your queries are using. So I could be pushing out data that you care about just to get this encryption scan done. So that's the reason why we really need some control over that. So obviously this generates a large amount of I/O. It can take a very long time. And there's no way to control it. We don't give you any way to control the speed at which this thing runs. And originally, we gave you no way to pause and resume. So that was the reasoning behind creating a suspend and resume syntax for TDE. So the way this works is very simple. Alter database name, set encryption suspend. That suspends the encryption. And this actually persists reboots. So if you were to reboot the server and come back up, it'll stay suspended. And then if you want to resume it, then you just set encryption resume. There is a dynamic management view, DM database encryption keys, that you can use to look at the status of the encryption scan. So that will tell you if you have one running, whether it's been paused or resumed, and it'll also tell you the last time the status was changed, so when it was paused. And if you are to restart the server or failover while the encryption scan is paused, then there will be a message in the error log. You will need to manually resume the scan, like I said, but we will log something in the error log that says, hey, you had a scan going and it's paused. You might want to resume it. Okay? All right, so do I need a trace flag? The reason why I threw this out there is we had some customers that really needed this functionality, and so we implemented a trace flag, 5004. And what that will do is pause the encryption scan, but it's really not a good way to do it. You want to be using the pause and resume syntax for TDE if you can. Okay, so this is in SQL Server 2019. Okay, so pause and resume encryption scan. Any questions about that? Yeah? Is TDE available in Standard Edition? Yes, it is in 2019. Yes, we just brought that into Standard Edition in 2019. Oh, more applause, thank you. What else? Yeah. Yes. So I'm sorry, say that again. If I have two keys, what? Oh, I see what you're saying. Okay, yeah, that's a really good question. So what he's saying is, okay, what if I rotated the key and then I pause the encryption scan? Some of my data would be encrypted with the old key, and some of it will be encrypted with the new key. That's true. You have to keep those old keys around. And honestly, anytime you rotate keys, you got to keep those old keys around because you need them for your backups as well. So it's always a good idea to keep those old keys around at least as long as you have those backups hanging around. So good question on rotating keys. Keep your old key and your new key. Yep. Yes. Is there any chance this will be coming backwards to 2017? There is a chance. It has not been discussed yet, but I think it's in theory possible, so we'll see. Anybody else? Okay, so let's end on the good stuff, because I think this TDE, I'm not sure how often people will use it, but resumable index operations, oh yes, these you will use, right? Okay, index maintenance pain points. I probably don't have to tell you these. What are your pain points for index maintenance? They take a long time. They take a long time. Long-running index operations. No way to recover after a failure. Let's say you fail over in the middle of an index rebuild. You are, in my favorite language, you are SOL. I won't tell you what that means. Come see me later if you don't know. Okay? If you restart, you lose everything. You have to start that index operation again from scratch. And there's no way to break this up across multiple maintenance windows. So let's say I want to do like an hour of index maintenance today, and then I want to do an hour tomorrow and an hour tomorrow. OK, can't do that. It's all or nothing. Transaction log growth. So here's another thing. So large indexes generate a huge amount of transaction log, and it is all one giant transaction, and therefore it's a huge amount of log that you can't truncate. So that is another pain point. OK, so resumable index workflow. Now, how many of you are already using online index rebuilds? Good, OK. So for those of you who are already using online index rebuilds, you are already having this kind of overhead. So Resumable is not going to add that much on top of it. Okay, so the way online indexes work is you have an existing index that you're going to rebuild, and you have a new index that we're going to rebuild it side by side, right? Okay, so we start our operation. We have to get a shared intent shared lock to read the pages, but we don't have to exclusively lock them. That's why it's online. If you're just doing a regular offline index operation, we're like exclusively locking things and you can't use it at all. So online means we're just doing shared locks. And then if I want to modify a row during the index operation, what do I have to do? I have now two side-by-side structures, old index, new index. I want to modify a row. It's in both indexes. Where do I have to modify it? Both indexes, right? OK, so if I have to do a DML operation, I have to do it twice. So there's your overhead. You are doing side-by-side operations. And if you do DML, it has to be done in two different places. So if you're inserting, updating, deleting, it has to be done in two different places. OK, here's where the resumable comes in. Now you can pause that operation. What do? Well, we keep everything hanging around. After you pause the index operation, if you need to do DML, you can, but you're still going to get that overhead. So even though the index build is not happening, which is the bulk of the CPU and I/O, let's face it, you do still have that dual path DML that needs to happen while the index operation is paused until it completes. So that still happens. But the cool thing is, later I can resume it. I can just pick up where I left off and continue building instead of starting from scratch every time. Okay, so then eventually, when it's done, I drop the old index and the new index is in place. I need a schema modification lock to do that. And then we're done. Okay, so that's resumable. I have a question already. Yep.
How long can the pause persist?
As long as you want. How long can the pause persist? You can pause as long as you want. Just keep in mind, you've got to have that side by side as long as it's paused. How does this work? Well, first thing is the operation is cut into small chunks. So rather than having one giant atomic transaction, you have smaller transactions, and they are committing as they go. So this means that your log should not grow as large, and you can checkpoint while all this is happening. It can be truncated while the process is going on. You can back up the transaction log while the process is going on, and you have those smaller transactions there. The progress is persisted in the database metadata. So we maintain metadata in your database as to where the progress of that operation is, and that allows us to start right back up when you hit that resume. So we do all your sorts happen there. We persist all the sort pages and that secondary index structure. All of that's there, and it's replicated to your secondaries. If you're doing availability groups, all of this is being replicated. So guess what? Failover, finish the index rebuild on the secondary. Pause, fail back. You can go back and forth. Okay? Persisted in the log. Yeah.
Do you have to manually pause, or it doesn't pause automatically if you do a failover or if something happens?
That is a good question. Let me go to my FAQ. Will the index operation automatically resume on a failover? The answer is no. You can resume, but it will not resume automatically. So if you fail in the middle of the index operation, or you restart or something like that, the index operation will be paused. It'll go into a pause state, but it will not automatically resume. Okay, so you need to look out for those messages, and there's some DMVs that you can look at that will tell you whether there are any index operations in flight. Yeah?
I guess two-part question.
Two-part question.
If you do a full backup while you have a resumable index operation, and restore that backup on another environment, would you still be able to see that pause index that you can resume on a secondary location?
Sorry, say that again. So if I,
You're in the middle of an index, you pause it, you perform a full backup, you restore that into another environment.
I restore it into another environment, can I pick up the index rebuild? So I'm not sure off the top of my head on that one, but I would think yes, because it's all in the database metadata. So in theory, if I've paused it and then I restore it, I should be able to do that. But I have never tried it, so I can't confirm. So, but I can try that later and we can see. Okay. Questions? Yeah. What about what? Oh, is this available in standard edition? So I didn't put that on the slide because no, this is enterprise only. So online index rebuilds are an enterprise only feature. Therefore, the Resumable is also on, enterprise only. Yeah. Oh, sorry. Does online indexing need to be enabled? Yeah, I should have mentioned that. Yes. In order to do this, you need both online and Resumable. There's two keywords. I'll show you the syntax in a minute. Yep. Yep. So after you pause, you say you don't want it. I have that on a slide somewhere, I think. But not here. OK, so sorry. So after I pause, I don't want it anymore, I can abort. So there's an abort command as well. I have a slide with the syntax. I think it's the next slide, but yeah. Yep. Is this feature available in Azure SQL Database? Yes, in fact. Online and Resumable is on by default in Azure SQL Database Compatibility 150. So if you're doing a supported index rebuild operation that can be online and Resumable, it will be online and Resumable in Azure SQL Database by default. Now it should, well, actually, hey, Joe, do you know this? When you create a new Azure SQL Database today, is it defaulting to 150 today?
No, so we're going to start rolling out with the default.
OK.
The general rule of thumb is once the latest version of Box SQL Server
Yep.
ships,
Yep.
GA this week,
Yep.
then we put into the train that new default will start rolling out. And then at a certain point, usually 40–50% of the data centers, then we do a blog post announcement.
OK.
Just making sure that we're not pre-announcing it if we have to roll.
Got it. OK, so for those of you who didn't hear Joe, what he said is once a new version of Box product GAs, which is this week for SQL 2019, that's when we start rolling it out into Azure. So it's going to take a little while for it to get rolled out. He said you will see a blog once we get to about 40–50%, you said?
Yep. And you
Yeah.
can bump it anytime. Like
OK, yep.
go to 150. It's just the new database default to 150.
OK, so just to be clear, that's the database default. Today, you can go and bump your compat up to 150 if you want to. OK, one more question, and then I'm going to keep going.
Cutting the operation into multiple smaller transactions, is that something that is also in an offline rebuild?
No, that's a good question. So that cutting it into smaller transactions, is that also in offline rebuilds? And the answer is no, you need Resumable for that. OK, so let me keep going with some of these FAQs. So will it affect performance? What do you think? It depends, of course. So if you're already doing online index rebuilds, it shouldn't be that much different. If you're not already doing online index rebuilds, you will have that dual path update while the index rebuild is running. So you could see some overhead from that. Also, it's obviously the more write heavy you are, the more overhead you'll have from this, okay, because you're duplicating the writes. Can I modify the underlying objects when the index operation is paused? So the answer to that is no. You can't do any DDL on these operations, so you can't alter the tables while the index is paused. You would have to abort the index rebuild, make whatever changes you want, and then start a new one. So what version do I need? So online Resumable index rebuild is available in SQL Server 2017 and in Azure SQL Database. Index create was added in 2019. So you can actually also create indexes with online and Resumable in 2019. And then, as I said, online and Resumable on by default in Azure for 150. Okay? And then are column store indexes supported? And the answer is no. You can do online create and rebuild of column store in 2019. That is something we added in 2019, but you cannot do it Resumable, online only. Okay, so how do I get it? Create or rebuild DDL now you need to add online equals on and resumable equals on. Or for your alter syntax, same thing. Online equals on, resumable equals on. Pause, alter index, the index name, the table name, pause. Resume, the same, just use the resume keyword. And then abort, abort. Okay, so keep in mind, if you pause an index operation, that those dual structures are there and will remain there until either you resume and the operation completes or until you abort. Okay, so if you don't want that overhead hanging around, you need to abort. Yeah? I think I read that you can't disable an index if it's in the process of a resumable operation. I'm pretty sure I read that, yeah. Like I said, I'm not 100%, but I'm fairly certain I read that. Also, just so you know, there is also a database scoped configuration. So you can alter database scope configuration, and you can set elevate online and elevate resumable to when supported. So what this will do is if someone just executes alter index rebuild, as long as that index supports online and resumable, it'll automatically make it online and resumable. So this way, you don't have to modify all of your index scripts. You can just change the database configuration, it'll do it automatically for you. This is also a way that if you're in Azure SQL Database and you're in 150, but you don't want online index rebuilds, you can turn it off this way. There's also a force off option that will allow you to turn this off in case you don't want it by default. Okay? So that's your database scoped. Yeah, I got more questions. Yep. Yeah. If you run out of space in the middle of an operation, will it abort or will it pause? I believe it'll pause. Like I said, I haven't tried that, but any sort of failure, which your database running out of space would be a failure, I believe just pauses it. Okay. Yeah, if you kill the SPID, same. It's going to roll back whatever the current transaction is, but I believe it should leave it. Again, I haven't tried this yet, but we can try this. If we have time, I can even try it today, but yeah. Okay, yep, question. Yep. So the question is, if I turn this resumable on, does that automatically make my transaction log smaller? Is that what you're saying?
Well, let's say turn it off. When we turn it off, automatically when we review it, that becomes a large transaction.
Right, so when you rebuild things online without the resumable keyword, then yeah, it's one transaction. It can be a large transaction. So you need to add the resumable to get this smaller transaction behavior. Yep. Okay, so let's go ahead and go over to that demo. Okay, so I'm going to close my ADR, don't save. Let's come here, resumable index operations. Okay. All right, so I believe I already have my DW here. So let's just try to rebuild this all. So what I'm going to do first is I'm going to copy this query, because remember what I told you about notebooks is you cannot run two queries at the same time in a notebook. If one's running, you won't be able to run another one. So what I need to do here is just say new query, and please connect to my, oh, actually I probably should, well, I think I have a use database in here, so let's paste that. Okay, so let's run this now. So what I'm doing here is selecting from sys.index resumable operations. Let's just see if anything is running right now. Okay, so nothing is running right now. Okay, so let's come over here and let's go ahead. Oh, duh, I'm sorry, I did it opposite. I was supposed to do this. All right, we'll put this in another window. Okay, all right, okay, so that's running. Let's come over here and let's play. Oh, shoot. Here. Okay, so now you can see my index is running, and it's 6% complete. So I'm going to go ahead and pause. Okay, so I paused the index, and let's run this again. Okay, so now you can see my index state is paused at 26% complete, and you can see when it started and the last time it was paused. And then this is the total execution time in minutes. So that's how long the operation has been running. Okay, so let's go back to that same window and resume. Okay. Oh, right, I can't use that shortcut. I have to fix that. Oh, and I got to go to the right database. Oh, the joys of working here. Okay, there we go. Okay, so now I am resuming. And you can see I'm running again, and I'm at 30% complete now. If I want to simulate a failure, I can do this. And again, new query. Okay, and let's start it back up again. Oh, sorry. I'm going to open Management Studio for this. The one thing I don't like about Azure Data Studio is I can't right-click on the server name and say start. I meant to keep Management Studio running for that, actually. So sorry about that. Oh, and I can't connect to Daenerys now because, right, because you're down. All right, sorry. SQL Server. Oh, not that's the agent. There we go. Let's start that. By the way, if you come to my migration session, I'm going to upgrade a Cowboys database to a Seahawks database. So that's tomorrow. Okay, sorry. So let's come back here, and let's go ahead and check our state again. Okay, so now I shut down the server, and you can see now it's paused. So I need to manually resume after a failure. Okay, so and then if you want to, I can go back, not to this window, to this window. And incidentally, the other thing you can do is, other than doing the resume, you can also just run the same alter index command again, and that'll also just start the same command, like start the index rebuild. So you can either alter index resume or run the same exact alter index command. Either one of those things will resume. So you can see now that it's running. Okay? So resume is really not just the resume keyword, also running the same. It's smart enough to go and look and say, oh, you're already running this. I'm not going to start a new one. I'll just resume the one that's already there. And then so let's watch this a little bit. 94%. 99, and it's gone. Okay? All right, so we've got 6 minutes left. So let me go through just the nice questions. So I've got a couple of slides here. Pedro and I recently wrote a book last May on T-SQL querying, so feel free to check that book out. I've got some links here for you to try. I have not uploaded my deck yet, but I will upload it to Pass, so this will be available to you so you can click these links, but we've got a bunch of short links. And we do have one shortcut to rule them all, so aka.ms wax SQL shortcuts, and you can find all of our other shortcuts because we have tons of shortcuts. Okay, and I did mention Bob's workshops. So when I'm saying Bob Ward, I'm sorry, not everybody knows who I'm talking about when I say Bob, but if I say Bob and SQL, I'm talking about Bob Ward. Or I could be talking. You're right. There's a lot of great Bobs. There's actually 2 Bob SQL, and they have a blog together. Anyway, sorry. I'm talking about one of those awesome Bobs, though. Anyway, Bob and Buck and Anna put out this SQL workshops, so aka.ms wax SQL workshops. This is a GitHub repository full of tons of free training for you to consume, but also for you to redeliver. So if you deliver training, you can take this, slide decks, demos, notebooks, all kinds of stuff, and you can use this for your own learning or for training others. So I really want to plug that. And then session evaluations, of course, everyone, please submit your evaluations. There's prizes and fun, but more importantly, then I know how to fix my presentation and make it better the next time I deliver it. So that would be really helpful. And there's my thank you slide. And now we have 5 minutes left to do more questions. Okay? So, question. So is there a way to automatically abort one of these resumable operations after a certain period of time? There's not a way, I don't think there's a way to abort a paused operation, but there is something you can do, like if you're not able to, so remember at the end, there's like this schema modification lock that you have to get. So if you can't get that schema modification lock, you can do something like wait at a low priority or things like that, and you can set in timers for that. That will automatically abort. You can set it to run for a period of time and automatically pause, but I don't think there's a way to get it to automatically abort. I'd have to check though, because I know you can get it to run for a certain period of time and pause, but I'm not sure if you can get it to abort. Oh, right, because you have maintenance plans that don't consider a failover, so they might be thinking they're starting from scratch when really they're resuming an existing or something like that. Is that what? Right. Yeah, and you don't want that stuff hanging around. Yeah, okay, I see what you're saying. Okay, other questions? Yeah. Any chance to see that index create on SQL Server 2017? I don't think so, but I mean, I don't want to say no for sure, but I don't think there's any plans for bringing online resumable index create to 2017. Don't quote me on that, though. Any other questions? Yeah.
For ADR, the SLAG, you said is in-memory. You know, does it have the same limitations as in-memory objects? Like no CPC, no limitations?
Oh, so the SLAG is in memory. Does it have other limitations like in-memory OLTP, you mean? No, not necessarily, because this is a different thing. There are some, I don't know of any. Do you guys know if there's any orthogonality issues with ADR turned on? Like, are there any restrictions where you can't be doing CDC or? I'm not aware of any. I haven't read of any limitations like that. I mean, I can definitely follow up with you on that and find out, but I haven't read of any limitations like that. If I had them, I would have put them in the slide deck for sure. Yeah. Other questions? One more. Yep. Any future resumable operations for things other than index rebuilds? I don't know of any off the top of my head, but again, I'm not ruling that out. It's possible that we could add resumable operations to other things. Yeah. Data structures, yeah, okay. All right, well, thank you guys very much. I really appreciate everyone being here. Enjoy your summit. And feel free to hang around if you do have more questions. I'm happy to stay for a while. Thank you, guys.